All right, I'm going to do another example of how we can analyze and sketch a rational function using the first derivative. All right, so first thing I'm going to do is I'm going to find my x-intercepts. To find my x-intercepts, I'm setting y equal to 0. Okay, cross multiply or multiplying both sides by x minus 2, I get 0 equals x squared minus 2x plus 4. Okay, I try to factor this. I'm looking for factors of 4 that give me negative 2, and there aren't any. So I know that to solve this, I would need the quadratic formula, quadratic equation. All right, so I'm going to check this out. When I plug in b, I don't even need to go too far because I can see from here I have in the inside 4 minus 16, which gives me a negative number. And if I have a negative under the radical, I know that this is only going to have imaginary solutions. So for my x-intercepts, that means that there are none. All right, now I'm going to find my y-intercepts. To find my y-intercepts, I set x equal to 0. So I have 4 on top, negative 2 on the bottom, which gives me negative 2. This is my y-intercept. Okay, next thing I can do is I can find my vertical asymptote. To find my vertical asymptote, I'm going to set the denominator equal to 0, x minus 2 equal to 0. I'm going to solve it. I'm going to get x equals 2. All right, last thing, I'm going to check out my horizontal asymptote. All right, because the degree on the top is 1 bigger than the bottom, that means that there are no horizontal asymptotes, but that means now that I have a vertical asymptote. So to find my vertical asymptote, I divide the top. I'm going to use synthetic. So 1, negative 2, 4 by the bottom. So positive 2 goes on the outside. 1 comes down. 1 times 2 is 2. 0, I add. 0 times 2 is 0. I get 4. This is my remainder. This is my constant. This is my x term. So that means that my slant asymptote is, because this is 1x plus 0, so my slant is y equals x. All right, so let me graph that stuff before I even find the first derivative. Okay, so I have no x-intercepts. I have a y-intercept of negative 2. I have a vertical asymptote of positive 2. And I have a slant asymptote of y equals x. So that means I start at 0 for y equals x. My y-intercept is 0 and my slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1, down 1. Okay, so now I'm going to use my first derivative to find possible critical values. So I'm going to write the function over again. Okay, the derivative of the top is 2x minus 2. The derivative of the bottom is 1. Okay, bottom times the derivative of the top minus top times the derivative of the bottom. And then it's all over g squared, but I'll do that in 1 second after I clean this all up. So I have 2x squared minus 2x minus 4x plus 4. So that's 2x squared minus 6x plus 4 minus x squared. I'm going to pull that negative into every term. Plus 2x minus 4. Okay, so I have 2x squared and negative 1x squared, so that makes x squared. Negative 6x and 2x makes minus 4x. And 4 and negative 4 makes 0. So the top is x squared minus 4x. And the bottom is g squared. G is x minus 2. Okay, so now to find my possible critical values, I'm going to set that equal to 0. I'm going to put this over 1, cross multiply. I get 0 times x minus 2 quantity squared is 0. 1 times this is x squared minus 4x. I'm going to pull out an x. I get x minus 4 equals 0. So my two critical values are x equals 0 and x equals positive 4. All right, so now I have some special numbers to put on the number line. I have 0 as a special number. I have 4 as a special number. And then I also have 2 as a special number, because that was my vertical asymptote. All right, so I'm testing intervals from negative infinity to 0, 0 to 2, 2 to 4, 4 to infinity. All right, so when I plug in, we'll go with negative 10 here. Negative 10 squared minus 4 times negative 10 over negative 10 minus 2 squared. So I have 100 plus 40, so positive over positive. Whole thing is positive, which means that section is increasing. All right, now I'll plug in 1. Okay, the bottom has to be positive. So I have 1 minus 4, which is negative. So negative over positive is negative, which means my whole graph is decreasing. Now I plug in 3. Bottom's still going to be positive. I have 9 minus 12, so that's negative on top. Negative divided by positive is negative, so the whole graph is decreasing at that point. All right, and then finally, I have 10 squared minus 4 times 10 over 10 minus 2 quantity squared. All right, so I have 100 minus 40, so that's positive over positive. The whole thing is positive, which means the graph is increasing. All right, so from negative infinity up to 0, I have to be increasing. But remember, that's my y-intercept, so I have to be increasing up to that point. Okay. Now from 0 to 2, I have to be decreasing. Okay, next. From 2 to 4, I have to be decreasing. Okay, now I need to know what point at 4, because 4 was my other critical value. So to find where I should plot 4, I'm going to put 4 into the original function. Okay, so I have 16 minus 8 plus 4 all over 2. So I have 12 over 2, which is 6. So that means that 4, 6 is an important point. 1, 2, 3, 4, and 6. Okay, now remember, 4 was my critical value, and it was going from decreasing to increasing, which means I have a relative minimum at that point. So I'm going to go from decreasing to that point to increasing. So I have a relative minimum here. And here I went from increasing to decreasing, so I have a relative maximum.